Hi, I'm Dr. Papia Bhattacharjee. This problem, we are looking into inverse of a function. It's a very important concept. So, this is all given. The function is given. F is equal to 4x. Informally, we have to get an idea of what the inverse function will look like. So before we proceed and solve the problem, let's first recall what we know about inverse function to understand more about inverse of a function. So this is the concept, informal concept of inverse. So function is like a machine. You have an input and you have an output. So say your input is x and the function is f. What f does, it takes x to an output, which we usually say y or f of x. So this is what f does, right? It takes x to y or x to f of x. Now what does the inverse function do? It reverses what f does. So inverse of f will take this value, the f of x, and take it back to x. That's what the inverse does. So it undoes what f does. All right? So let's think about our problem here. Our function is 4 times x. So this function is such that every input or each input, which is x, is multiplied by 4. Okay? That's the operation. That's what the function is doing. You input an x, your output is 4 times that input. So what do you think the inverse will do? It will do the reverse operation, and the reverse operation of multiplication is division. So what the inverse will do, f inverse should take each input, and the input of f inverse is the output of f, so it takes something here, and it will divide by 4. So each input is divided by 4 because that's the inverse operation, right? So let's check, let's write it down. So what is f inverse of x? If we follow this rule, so each x is divided by 4, therefore f inverse should be x over 4. Now, is this correct? Let's check. And the best way to check is the rule between f and f inverse, that they reverse each other. And what does that mean? That means that when you take f and then apply f inverse to it, you should get x, right? So f and f inverse basically cancels each other. So that's one way, and the other way is also true. If you take f inverse and then f, you should also get x. So this is exactly represented by this diagram, right? You take, say, the second one, you take f, and then you take f inverse, you come back to x. Or the other way, you do f inverse first, and you then do f, you come back where you started. So let's see if we can check these two facts using the two function expressions that we have. One, we have f, and the second, we have f inverse. So for the first one, for this one, let's figure out what is f of f inverse of x. Okay, now f of x is given by this expression, 4x. So it's almost like this is what you are evaluating the function. So you're evaluating f at an expression here. So almost like there is an empty box and you have f inverse inside that box. So in the expression for the function, you will have 4 times, instead of x, you put that empty box and you put the f inverse in that box. Okay, so this is 4 times f inverse is x over 4. So this is 4 times x over 4, which means the 4 cancels and you do get x. So the first one is true. Let's check the second one. So for the second one, we have f inverse of f of x. Now in this case, f of x is in the empty box, and you use the expression of f inverse right here. So f inverse is x over 4. Instead of x, you have the empty box over 4, and inside the empty box, you will plug in f of x. All right. So what is f of x? It's 4x. So inside the box, you have 4x divided by 4. So this is just 4x over 4. Again, the 4 cancels, and you get x. So this is correct. This is correct. Both checks. Therefore, our inverse function expression is right here. That is the inverse of f that's given. Thank you.